Let's create an adjacency list such that adjacency list at V contains all the adjacent vertices of vertex V.
So first, let's create an adjacent list variable, which is an array generated by one element array 0 multiplied by n nodes. And then we use a for loop. For I in range of n, we assign empty array into every element of adjacent list. So this adjacent list will contain an empty array. And then we iterate every edges for I in range of lengths of edges. In the ith edge, we append the second node into the first node adjacent nodes array, and we append the first node into the second node adjacent nodes array. And then we use a for loop. For I in range n, we assign an empty list into every element of the adjacency list, and this operation takes O of V times. Let's say we have edges array, which have the edge 1, 2, 3, 4, 5, 3, and 4, 5, and then each node have its own array and represent the neighbor array, which node is 0, 1, 2, 3, 4, 5. So in the first edge, we put 2 into 1's position and put 1 into 2's position, and in the second edge, we put 4 into 3's position and put 3 into 4's position, and in the third edge, we put 3 into 5's position and put 5 into 3's position, and in the fourth edge, we put 5 into 4's position and put 4 into 5's position.
And about complexity, building the adjacency list will take O of E time operations as we iterate over the list of edges once and insert each edge into two lists. Also, building the adjacency list will take O of E space. Let's use a for loop. For I in range lengths of edges, we iterate edges array into the adjacency list. So for every edges I, we have first node and second node. These two nodes will form an edge. So in an adjacency list, at the first node position, we append the second node into it, and at the second node position, we append the first node into it. So that is how we generate the adjacency list. And the time cost is O of E times, and the space cost is O of E space.